Welcome back to my Let's Play of Khan Academy, World of Math. Now up to 390 skills mastered. 982, still not started. So we gotta keep going. What fun math problems shall we do today? Martha needs 22.25 strawberries for every 5 smoothies. Number of smoothies 44.5. 89. Nice. How many significant figures does that number have? Every month, a group of 46 students writes essays. Each student writes 2 essays, and each essay contains 1,000 words. How many words do the students write every month? 46 times 2. 92,000. A rectangle is, given these coordinates, what's the length of AB? 3. Which of these are quadrilaterals? If I remember right, it's...
I have a bunch of shapes here. Let's think about 4, 3. So you might be going in the same direction. 2 lines we call
quadrilateral, 4 sides. Squares, rectangles, rhombuses, and trapezoids. Create a quadrilateral with vertices the following points: 8, 0, 8, 7, 0, 0, 2, negative 6. Oops. I clicked off the dumb page. Is it going to make me redo this thing? Yep. Ridiculous. 8, 7, 0, 0, 2, negative 6. All right. Write your answer in simplest form. Flip that around. Negative 1/7. What? Oops. 25/7. So let's see. 5. There we go. 4 significant figures. What? How does it not have 4?
Let's see if we can learn a thing or two about significant. 0 produces 0. 3 between non-zero digits. So in this nearest 1,000. So it depends significant that we actually go to
Rules.
based zeros, not trailing zeros. What do we do with them? They are not sure. Here, there's a decimal, so you count the trailing 0. There's a decimal here, so you count the trailing zeros. There are no trailing zeros here. And over here, well, the way I later put a decimal here, here you would count it. So if you have the decimal there, you would count all 5. If you didn't have the decimal, if you just had 37,000 like that, it's ambiguous. And if someone doesn't give you more information, your best assumption is probably that they just measured to the nearest 1,000, that they didn't measure exactly to the one it just happened to get. It's not clear, heroes. A notation, and there is a notation for specifying bar. We're able to measure, but then you would put the bar above that 0, or the bar 2. You could write this as 5 to the 4th, you would unsign it. Instead of doing this digit, Instead, you can represent it with a decimal digit. So hopefully that helps you out. And then
What does the answer want? Does he want 1? Ridiculous. Needs 3 and 1/2 of lettuce for every 6 salads. So 7. And then 10 and 1/2. CD 4. What's a prime factorization of 13? 13's a prime, isn't it? Yeah, it is. So 1, or is a single prime number like 13? Square root of 64. 8 times 8. 64. Messed up 2. Plot the data in a scatter plot. So for meditation, sleep hours is 4.5. 9.5. 8 sleep hours is 9.5. 10. Oops, this one. I'll get rid of that one. This one is 10. Meditation is 8.5. 4, 8, 10. 4 minutes of meditation is 6. 18 meditation minutes is 10. And 4 is 7. Prime factorization is 3 times 7. 3x7. Sounds good to me. It's divisible by 10, yes. Are all numbers both divisible by 10, 12, and 10 also divisible by which of the following? Maybe 20. I don't know if that's really true. Oh, internet cut out in a second. Alright, it's back. Divisible by which of the following? Let's see how he does this.
in this video I want to do a bunch of example problems that show up on standard. That if a number times 3 that's divisible by 12. Now, any number that's by 20 divisible by both, you have to have 2 2's, a 3, and a 5. 2 2's and out is going to this number right here are the same. It might not exist because the number might be 12 is a 2 times 2.
Okay.
2 times 3.
Find the prime factorization and so on. Alright, so let's flip over to our drawing pad. So 2 times 3 is 12, right? 6, 12. 2 times 5. So basically that times 5. So 12 times 5 is 60. Isn't it? Is that not right? That is weird. Let me read and watch the video again.
In the prime factorization of 4 times 2 to 12, which is 12 divisible by 20. And if you're this way, then 2 2's and a 5 for 20. And you can verify this for yourself, that this is divisible by both. Obviously, if you divide it by 20, about it, 2 times 10, 5. Or another way of thinking about it, it needs to have 2 2's and a 5 in its prime factorization. Now, if you're divisible by both, you have to have 2 2s, a 3, and a 5. 2 2s and a 3 for 12, and then 2 2s and a 5 for... You can verify this for yourself, that this is divisible by both. Obviously, if you divide it by 20, let me do it this way. If you're dividing it by 20...
Okay. Well, let's see. Any of those answers. Did I screw something up? Huh. Well, I don't know. Let's get a hint. Maybe I should just guess. It doesn't make much sense to me, but whatever. How many significant figures? 6. Move all perfect squares. Okay, 108 is equal to 454 times 2, which is 20 plus 2, 25 plus 2, 27 times 2 times 2. 27 is 3 times 9, yeah. That's 18, yeah, 27. 2 times 2. And 3 times 3 times 3 times 2 times 2. So we're looking at, oops, this is 2. So we're looking at 6 square root of 3. Something like that. 6 square root of 3. All right. All numbers divisible by both these two are also divisible by what? Let's try this crazy math again. So 2 times 12, which is 2 times 6, and 6 is 2 times 3. So that's 6, that's 12. That's 24. 2 times 7. So it looks like I just multiplied 24 by 7. So 24 times 7 is 8. Plus 2, 14. 168 maybe? I'm obviously doing this pretty fucked up. 2 24 times 7. Yeah, I don't know. Let me go get a hint to figure out what the hell he's doing here. Isn't that what I have? What the heck are you talking about, 84? Where'd the other fucking 2 go? It's right there, and then he doesn't have it right here. It doesn't make any sense. Because this shit is this? This shit is 2 times 2 times 2 times 3 times 7. 168. And then magically he just gets rid of the other 2. Huh. Like, he doesn't explain why he gets rid of the other 2.
In this video, I want to do a bunch of will also be divisible by this cancel out. We're going to cancel out is 2's and a 5 for 20. And you can verify this for yourself, that this is divisible by both. Obviously, if you divide it by 20, let me do it this way. Dividing it by 20 is the same thing as dividing it by 2 times 2 times 5. So you're going to have the 2's are going to cancel out, the 5's are going to cancel out. You're just going to have a 3 left over. It's 2 times out, and you just have a 5 left over. So it's clearly divisible by both. And this number right here is 60. It's 4 times 3, which is 12, times 5. It's 60. This right here is actually the least common multiple of 12 and 20. Now, this isn't the only number that's divisible by both 12 and 20. You could multiply this number right here by a whole bunch of other factors. I could call them A, B, and C. But this is kind of the smallest number that's divisible by this numbers that we see divisible. 2 times 2 is divisible into it, because we have the 2 times 2 over there. We know that 3 is divisible into it. We know that 2. The only really address it. They might just be 1s, or they might not exist, because the number might be 60. It might be 120. Who knows what this number is? So the only numbers that we know can be divided into this number, well, we know 2 can be. We know that 2 is a legitimate answer. 2 is obviously divisible into 2 times 2 times 3 times 5. We know that 2 times 2 is divisible into it, because we have the 2 times 2 over there. We know that 3 is divisible into it. We know that 2 times 3 is divisible into it. So that's 6. Let me write these. This is 4. This is 6. We know that 2 times 2 times 3 is divisible into it. I could go through every combination of these numbers right here. We know that 3 times 5 is divisible into it. We know that 2 times 3 times 5 is divisible into it. So in general, you can look at these prime factors, and any combination of these prime factors is divisible into any number that's divisible by both 12 and 20. So if this was a multiple choice question, and the choices were 7 and 9 and 12 and 8, you would say, well, let's see, 7 is not one of these prime factors over here. 9 is 3 times 3, so I need to have 2 3's here. I only have 1 3 here. So 9 doesn't work, 7 doesn't work, 9 doesn't work. 12 is 4 times 3, or another way to think about it, 12 is 2 times 2 times 3. Well, there is a 2 times 2 times 3 in the prime factorization of this this least common multiple of these two numbers. So this is a 12. So 12 would work. 8 is 2 times 2 times 2. You would need 3 2's in the prime factorization. We don't have 3 2's, so this doesn't work. Let's try another example, just so that
Weird. So he's looking at the prime factors of these dudes also, and then figuring out what fits. Which of these dudes have 2 times 2 times 2 times 3 times 7. Have some combination of them, and any of them could be missing, but it can't have extra stuff. So 84 fits in there. Yeah, so since this is part of this longer one, all numbers which are divisible by are also divisible by 84. Alright. Know how to do that now. Several mammal. Which statement is the most accurate interpretation of the data? Species with higher heart rates tend to have longer life expectancies. No, higher heart rates tend to have shorter. Yes. 86 markers. Fewer. Let's see. 86 minus 20. No, sorry. 80. Sorry. 68 minus 26. 2, 4. 42. Scatter plot. Let's see. Sick days. 6 days. T-shirts. 7.5. Sick days gives me 7 T-shirts. 0.5 sick days gives me 7 T-shirts. 3 sick days gives me 7 T-shirts. 4 sick days gives me 5 T-shirts. 9.5 sick days gives me 6 T-shirts. How many significant figures does this have? I think the answer is 5. 5, 6, 7, 8. Divisible by 2, yes. Count backwards. All right, I can do that. Which number's next? I think it's gonna be a 9. How many significant figures does this have? I think we're gonna count that. So I'm gonna say 5. It's probably 4 though. So dumb. I always get these wrong. Make an obtuse angle. It's greater than 90 degrees. Shows the relationship with test grades, which statement is most accurate interpretation of the data. Students with larger shoe size. Not really. All numbers. Okay, here's another fun one for us to do. Okay, 23 is prime, so let's clear this out. So we're looking at 2 times 6, which is 2 times 3 times 23. Now you have to prime factor all the other dumb numbers. So 2 times, so 110 is 2 times 55, which is 5 times 11. And 88 is 2 times 44, which is 4 times, what, 10? No, 11. So that's not right. 122 is, what, 2 times 61. $92 is 2 times, is that 46? which is 23. It looks like 92. All right. Divisibility got to level 2. Significant figures. Totally suck on significant figures. Put 6 flowers in the box. I can do that. Yeah. Make an obtuse angle. Greater than. You spin the spinners shown below once. What is P of shaded area? Round your answer.
What I want to do in this video is give you at least a basic overview of probability. Sides are EQ ways. My heads, or you could get tail. Flipping a coin. So this flip, you view this as an experiment. I know this is a kind of experiment.
Yeah, it's like 1/2.
And or one roll of the die. Well, of getting an even number. So once again, you have
Okay.
Find the probability of pulling a...
So the probability of the shaded area is, what is it? Each sector has an equal area. So there's 1, 2, 3, 4, 5. So it's 2/5. How many significant figures? I need to watch this crap again. I'm gonna pause the video and I'll be back. Okay, watch those videos. So this should be 3. All numbers divisible by 20 and 23. Let's see. 2 times 5. Let's look at what 85 is. So 2 times 5 is 20, and 23 is prime. And 85 is 5 times 13. So right, no, not 13. Let's see, we got 35 left, so 17. That's not 85. How about 46? 2 times 23. Yeah, 46 sounds good. Going through a revolving door that needs 160 degrees to rotate to allow it to pass through. The wind was strong enough to push the door around 40 degrees, but needs to push it the rest of the way. Okay. And I think that's actually a good stopping point for the episode. We got to almost 400 skills mastered in math. Thanks for watching. See you next time.